Okay, let's move on. This I forgot about you. Okay, she asked me her question during the break, and how about yours?
You said if there's no function definition in base class or study function, the abstraction occurs and all functions became virtual, right?
No, I didn't say that. I said if in the base class, if you have even a single pure virtual function, your class becomes an abstract class. Okay, your class becomes an abstract base class. Here in this case, I have 1, 2, 3 pure virtual functions, and this WinApp is an abstract base class. Okay, it is enough to have just a single one. Okay, remember my employee class? In my employee, I have many functions such as get name, set name, get address, set address, etc. These are all non-virtual and concrete functions, and I defined all of them. I have only one function which is virtual and pure virtual, so this is enough to make my employee class an abstract class. Okay, if I don't override this print check in hourly employee class, then my hourly employee class becomes another abstract class, because it doesn't define this print check function. Okay, so it is not that difficult. Okay, just ask a question. Yes.
Can we define virtual static functions?
Can we define virtual static functions? Can you? Virtual and static. It's a good question. Trying to combine two things that we have learned before. Virtual and static. To make something virtual, for example, virtual, to make a polymorphic call, you need a pointer to the base class or a reference to the base class, right? Pointer to a base class or the reference class, base class, object. For the static functions, we don't have any objects, right? We don't have any objects. That's why for the static functions, we cannot have any pure virtuals or the virtuals, because statics, we don't need objects. They run like a global functions. That's why for the statics we don't use any virtuals. That's a compiler error. Statics are like, you should think about statics like they are global functions, special scope global functions. And since we are talking about objects here, types of the objects and etc., we say that we determine during the runtime the type of the object and we call the function accordingly. Okay, for the statics we don't need objects. That's why the idea of polymorphism and static functions doesn't work together. Okay, good. Any other questions? Okay, so let's move on. 20. Okay, we talked about this virtual. We talked about overriding and these. Why not all pure virtual functions, abstract base classes? Okay, we said that this is a relation, is a very important relation. Okay. There is a relationship between sale class and the discount sale class. Okay, a discount sale object is a sale object, but the opposite is not true. Opposite is not true. We cannot say that a sale object is a discount sale object. We cannot say a circle. We can say this is shape and circle. This is circle and this is triangle. Okay, and there is a relationship between these two. We say that circle is a shape, triangle is a shape, but the inverse, the opposite is not true. we cannot say shape is a circle. We cannot say shape is a triangle. Okay, so this is something we already know, and now we are gonna use this to make some programming, and we will see something happening. We have a pet class, evcil hayvan pet. Okay, and it has it is a very simple class. It doesn't have very constructed. It's a very bad class, but for the sake of simplicity, we are writing these kind of classes. Okay, my pet class name and virtual void print. Good. And this is not pure virtual, so it will print my name. Okay, and we have another class named dog, but this one is derived from pet class, base class. It has another field, data member breed, cins, köpeğin cinsi, and we are overriding this print function. Okay, so it's a simple hierarchy, very simple. And let's try to do this. Let me try to, let's say, if I say I have a dog D and I have a pet P, how do I see this in my memory? In my pet P, there is a name field. Okay, my name of my pet is Boncuk. Okay, and in my D object dog, of course, there are two things now. There is a pet field, right? In my pet, there is a name, and there is the other name, and there is this breed field, breed. Okay, and let me say here for my dog name is Alaj and breed is Kangal. As you know, Kangal dogs are named Alaj all the time. You know this, right? If there are no other Alashes in the world, then it has to be one. Okay. So this is what happens when I declare these two objects. So since there is an is a relation between these, there is an is a relation. So dog is a pet. Dog is a pet, right? So if dog is a pet, then if any function that accepts a pet object can receive a dog object, right? Let's say I have a function void f pet p. It does something. I don't know what it does. When can I call this with this fp? Yes, of course. Can I call this with D? Yes, I can. Okay, both of them can get called. I think you have a question. It's the question that I want to ask you actually. Ask me the question. I will ask you the same question.
Why are we use virtual text in dog class in cows?
That's not the question. Well, ignore this virtual right now. Ignore it. I mean, because you didn't see the implementation. In the implementation, for example, this one, when you say print, it will say that this is a dog object, and its breed is this, and its name is this. Okay, so they will print different things. So ask me another question. You should be wondering about something right now. And another hands. Two hands. Think about the problem here. Let's do this. Let's do this. Cout p dot name. What does this do? Does it work for this function called fp? fp. Does it work for this one? fp? Yes, it should, because pet is sent here and I have the name data member and it prints the name. So it doesn't matter for this one, Boncuk will be printed, and for fd, Alash will be printed, right? Both of them will work. So the question is what? Yes.
You send it is a call by value.
Yeah.
So you can't use the dogs print function in that.
Well, I didn't use print, so I didn't use this virtualness. So the thing is this. Remember, where do I put this pet p in my memory? It is in the stack, right? But it's a pet object, right? It's a pet object, but it lives in the stack. When I send a dog object to this function, what happens to the extra part here, right? Because this function f needs to keep a pet object, and inside the pet object, I don't have any breed data member position, right? This is just a simple pet object. When I write this function, I write this function against this code. That's this simple code. All I know that in P I have a name field and I have a print function. So I am using this name field right now. Okay, since it is public, I can use it. I prefer it that way. It's a bad design decision, but to make this thing simpler, I choose this way. Okay. So when I send this D to this function sees this name part of that D, but it doesn't see the breed part, because there is no place to put that thing. There is no place to put that breed part inside the P object of this function. Okay, so that part is sliced out. Sliced out, and this is called slicing. Slicing. Okay. Slicing is the process of ignoring the extra information that you are sending a function, or for example, I can do this too. I can maybe do this. P is assigned to E. Okay, P is a pet, E is a dog. Since there is an is a relation, right? On the left hand side, I need a pet object, and I can use a pet object or a dog object here because there is an is a relation. Okay. So this is the process of slicing. This is sometimes good and sometimes not good, but you should know about this happening. Slicing is happening. Yes.
What if we send pet with reference?
What if you send? Yeah, that's a good question, but keep that question in mind and ask it again in 10 or 15 minutes. Before that, I need to discuss some other stuff. That's a good question. Or similarly, you may ask, what if I send a pet pointer, not the reference? It's the same thing, yeah. Same good point, yes.
So, two questions. Does slicing lead to memory?
No. With the slicing, you are not doing anything bad, okay? It's just slicing, it's just a behavior, and you should know what is going on. That's why I'm saying slicing is not always, slicing is not a bad thing, okay? Sometimes you want slicing, but here I am talking about slicing because you should know about slicing. It's not memory leak. It's not a thing that you should always avoid. Sometimes you prefer slicing. There is no way to disable it, because if you send a D object, a dog object, to a function that needs a pet, this pet can hold only this much information, the name. There is no other memory position to keep the extras of this new object. Okay, that's why the compiler has to slice your object into smaller parts and ignore the extras. Okay, that's what happens with this. For example, here when I do this assignment, assign D to P, so I will copy this Alash name to here instead of Boncuk, but there is no place to copy this here to there, right? So slicing happens. Slicing happens. I am not saying that slicing is bad, but if you don't know what you are doing, you may end up in a bad situation. That's what I am. But that's why we are talking about. And this was there was a very good actually a suggestion. Why don't we use references or the pointers then? So that I mean, if you don't like slicing, then that's the solution. And we'll talk about that. Okay, any other questions? I think there was a question, right? No. Okay, how about this? I can do this, yeah, with the slicing, with the cost of slicing. How about this? DP. This one works because there is a is-a relation. D objects are actually, dog objects are actually pet objects, and I can use it. But this one doesn't work because pet objects are not always dog objects, right? So this one doesn't work. This one works. Okay? So the compiler will not let you do this kind of thing. If the compiler did it, if the compiler allowed you to use this kind of a notation, assign this one to, how do you assign this one to this one? Okay, I write Boncuk in the name part. How about this part? This part will be assigned, will not be assigned anything, so it will keep junk in it. So that will be a bad thing. I mean, much worse than slicing, if you think slicing is a problem, because you are leaving some uninitialized memory location. Okay, you cannot treat your pet object as like dog objects. That would be a bad thing. That's why this is not allowed. Okay, that's why this is not allowed. Okay. By the way, if I had a pet reference and I send P and D, since I am sending a reference like sending a pointer, nothing is sliced. Okay, nothing is sliced. Or let me do this. Let me not use this one. Maybe this is more. Maybe this will be more explanatory. Pat PTR. Here I am sending with the red address of P and address of D. Okay, I have this one PTR, and if I do this PTR print, everything works fine, no problem, because this F doesn't know which print to call, this one or this one. During the runtime, if I call this F with this one, it will call the pet print. For this one, it will call the dog, and during the runtime, this F will figure it out itself. There is no slicing happening here because I am not sending the object call by value. I am sending the pointer of the object, address of the object. So this function F follows that pointer and it finds the object, and it doesn't slice out anything. The object stays the same. It just uses the name part and the print part of the object. Okay. Or I could do this too. I could, instead of saying this, I could say name, right? This should work, no problem. How about this? What happens if I write this? Does it compile? It will not compile. Why? Because the function f, when it compiles, says that ptr is a type pointer type pet, and when you say ptr arrow breed, I don't see any breeds in here, right? I don't see any breeds, so it will not compile. But you may say that when I call this f with a dog pointer, there is a breed in it. I know that, right? I know that if I make this call, there is a breed in that object, but the compiler cannot know that you will call this function with a dog object, right? All the compiler knows with this case, it knows this code and it knows this one. It says that I will get a pet pointer, and with the pet pointer there is a name field and a print field. That's it. I don't have anything else. The compiler knows it. So this will not compile. Okay. So the good thing is here, this will not compile, and here maybe I can say name. This will compile, of course, but there is no polymorphism happening here because name is the name. So with the polymorphism to happen, I should say print. Call this print function. Of course, with the print function, I should not write this. Okay. So the is a relation is important. Compiler knows about the is a relation, and is a relation is a one-way relationship. Derived class is a object of the base class, but the opposite is not true. And if you do this with the objects themselves, okay, there is a slicing happening. There is a slicing happening with the object themselves. But if you use the object pointers or the object references, slicing does not happen, but still you cannot reach the extra data members or the functions of the object sometimes, because this function doesn't know about the derived classes yet. Okay, any questions? Let's go over the book's example again. A dog and a pet. Notice member variables name and breed are public. Okay, just for the sake of it. Okay, I have dog and pet. V dot name is tiny. V dog breed is Great Dane, so it has two things. And I do this. Can I make this assignment? V pet assign V dog. Yeah, because there is a relationship, so I can make this assignment. These are allowable. Okay, can assign values to parent types but not reverse. Pet is not a dog, not necessarily. What do I mean by not necessarily? Sometimes pets are dogs, but not always. Dogs are always pets, right? But pets are not always dogs. Right? Some of the pets are not dogs, some of the pets are cats, right? So that's why it says not necessarily. Okay, so the slicing is this. Notice value assigned to vpet loses its breed field. Okay, you cannot say vpet.breed because the type of vpet is pet. Inside pet class there is no breed, and it's called slicing. Might seem appropriate because we designed it that way. Okay, you lose some of your data when you make this assignment. When you make this assignment, you lose some of your data because you are treating yourself like a pet. Okay, and it's called slicing. It's called slicing. I wouldn't call this a problem. The book says it's a problem. I wouldn't say it's a problem. I would say it's a slicing property or slicing mechanism. It's just something expected. There is no place to fit everything in inside a pet object and inside a dog object. Inside a pet there is only name. Inside a dog there is a name and breed. Okay, so there is no way to fit everything inside the object to this one. I can make this assignment. It's possible. Yeah, this is possible. I can make this, but I would make this assignment with the slicing. I will leave the breed out. Okay, so how the if you don't like the slicing, how to handle this issue? Okay, how to handle this issue? So we use dynamic variables or the references like this one. Let's draw this memory configuration right now using a blue color. It says pet pointer ppet, so I have a ppet variable. Initially I don't know its value, and I have a dog pointer pdog, right? Okay, when I make a new dog object, here is my dog object inside my memory. Its name field is tiny, and its breed is Great Dane. Okay, and I will assign the address of this object, this new object, to pdog. Okay, so pdog is a address, and it points here. Since there is a relation between pets and dogs, I can make this pointer assignment too. When I make this pointer assignment, I do this. So both pointers are pointing to the same object. After this line, both of them are pointing to the same object. Okay, pointing to the same object. I can easily print out pdog name, pdog breed, right? There is no problem to printing these two out, but this is not allowed. Ppet breed, ppet object is here breed. The compiler will not let you compile this line. Okay, this is illegal. Why? I have it here. I'm pointing to a dog object, and there is a breed in here, but the compiler cannot know this ppet will always point to a dog object, right? It points to it definitely points to a pet object, and inside the pet there should be name all the time, but inside the pet it doesn't see any breeds. Inside a pet just there is a name and print. That's it. There's nothing else. So when the compiler compiles this one, it cannot allow such annotation. This is illegal. Again, this the opposite of symmetricity between the base and the derived classes. Derived classes are always base class objects, but the base class objects are not always derived class objects. That's why this is illegal. Yes. Yes, sure. Yeah, derived classes can friend the base classes, but that wouldn't be that meaningful because the base class doesn't know anything about derived classes. Right? When you write your base class, there are no derived classes yet. So if you make your base class as a friend of your derived, if you make the derived class as a friend of your base class, since you did not write the derived class yet, you cannot use that friendship relationship. Okay? Yes, you may, but doesn't work very well. Yes.
So here in this example, is the dog part and memory leak?
No, there are no. Memory leak happens with the memory allocation and deallocation. We are not doing any memory allocation deallocation. Okay, maybe you may talk about dangling references. Is this a pointer pointing to some place that it doesn't belong to, or anything like that? No, there are no dangling pointer problems here either.
But do we store ppet as the size of a dog?
Ppet is a pointer. It's just 8 bytes. This is pointer 8 bytes. These are addresses. Okay. These are two addresses. Those are. I mean, the size of the ppet and the size of the pdog has nothing to do with the size of the pet objects and dog objects.
If the ppet, if only ppet points to the pdog object,
yeah.
Reference, but we can't use breed member.
Yeah.
For example, isn't that breed member?
No, it's not gone. It is there. It is hidden there.
But
That's a very good question, actually. Let's say I have this picture. Let's say instead of saying this, let's say I have P pet. Yeah, that's a very good question. Actually, that would be my topic for the next 10-15 minutes. If I do this, P pet gets this new dog. Let me go back to my initial stuff. Nothing is assigned yet, and I have a new object. So here I have this, right? P pet is pointing to a dog object. It can happen because there is a relationship, right? Each dog pointer can be treated as a pet pointer. Okay, then of course when I say here this one and this one, this is P pet and this is P pet, this will work and this will not compile, right? This will not compile, even though there is a field in my object that can keep this breed information. This will not compile, right? This will not compile. I cannot write this here. So it's not memory leak. It's not dangling reference. Okay. We have that field, but I can't access it. How about this? If I P dog, P pet. If I can write this, P dog gets the value of P pet. Maybe I will do this, but this is not allowed either, because I cannot, what did we say? We said that we cannot use pets as dogs, because there is no relationship between pets and dogs. We don't say each pet is a dog, right? So this is not allowed. If this is not allowed, then how can I make this picture? How can I make this? How can I put this arrow in here? I need to change this breed thing. If I cannot get a dog pointer pointing to this object, I cannot access this breed. I know that my breed is there because I made this assignment myself. You might say that, okay, you wrote your code wrong. Write it like this way: P dog assigned new dog. Yeah, but I didn't do it that way. I mean, the pointer is passed to me, and they said that even though you are keeping a pet pointer to your object, it's a dog object. Yes.
If we had a dog constructor that takes a string as a root,
A dog constructor. Yeah. Okay.
it will just create this.
Oh, you mean that? You mean that? Yeah. Well, I mean, I might change the breed field later. Okay. I don't have that constructor. It's a very simple class. You are saying that if you designed everything carefully at the beginning, yeah, maybe, but I might have to use the setters and getters of that dog class, right? So how am I gonna get this? How am I gonna get this arrow from here to there? The compiler will not let me do this. One thing is this. Instead of writing this, since we are C programmers, okay, we are in a different class than other programmers in this world. We can do what is our superiority. We can do anything we like. Do this. Okay. Dog. No. It's a dog pointer and P pets. I told the compiler that just shut up. I am doing this myself. Okay, I know what I am doing. The compiler will tell me, okay, you are the boss, and I will do it. I forced this assignment. This assignment is okay because this is 8 bytes and this is 8 bytes. I am just copying values from these 8 bytes or 4 bytes to these 4 bytes. That's it. Okay. And I know that I am doing the correct thing because pet is pointing to a dog object actually, and I can make this assignment now. Okay, so if I force it, it will happen. This is a very dangerous thing. It's a very dangerous thing. I did this because I was sure that this pointing will point to correct thing. Okay, if on the other hand, if on the other hand if this pet is pointing to a pet object instead of a dog object, this assignment will give me some kind of a what? If this was the case, let's say instead of dog, I have a pet object in here, right? Since I have a pet object, I don't have this breed anymore. Pet is pointing to a pet object, and I said that P dog is now going to a pet object. Now when I say P dog arrow breed, it will try to write somewhere in the memory that doesn't belong to me, right? So I am writing a bad place. So remember what I said, this is dangerous. This is dangerous because I should know that definitely what I am pointing to is a pet dog object when I do this one. Okay, when I do this one. So assigning in this direction, okay, assignment in this direction may cause some slicing problems sometimes, okay, but that's okay. I can make this assignment all the time in this direction. But if you try to do the assignment from base to the derived classes, it is problematic. The compiler doesn't allow it, but if you force the compiler, then there will be some junk variables, or even worse, there will be some memory issues. So I should be very careful about these kind of forced assignments. And in fact, we don't do this at all. It is suggested that don't make kind of assignment at all. But what if I need to? I mean, what if the picture is like this? I know that there is a dog object in here, okay, and there is a breed in here. If I make this assignment, things will work. Okay, I know this one. So there is a way to saying that what kind of pointer do I have? Okay, pet pointer. Okay, what kind of object it is pointing to? If it's a pet object, then I will not make this assignment. If it's a dog object, I will make that assignment. Okay, I can do that too, because C++ produces code for each object. The object knows its type, and we will see how that happens in a few slides. Yes.
How can we be so sure about pet is dog? Because like we use it usually as a generic, so that means
we cannot. Yeah, that's why. I mean, that situation is very difficult to achieve. In this case, I was sure because I wrote this simple 4 lines of code. For the generic cases, we cannot know that our object is a certain type of objects unless we ask it. Ask the object, what is your type? If it says, I am pointing to a dog object, then I will make that assignment. If it is not the dog object, then I will not make this assignment. Yes?
2 questions. Why didn't we use static cast?
Why didn't we use a static cast? Because static cast is something, it behaves better than this one. This one doesn't ask any question, it just makes this assignment. It behaves like a C code.
The second question, if we make pet new pet.
It's a very good thing that you understand C humor, actually. Yeah. Just, I mean, reading a code and laughing at it is a good sign. Feeling the code, yeah, that's a good thing. Sometimes you feel sad, and sometimes you feel happy when you that shows that you are becoming a good engineer. Other people won't like it, but you don't need other people. Engineers are enough for you. Yes. Yeah.
We made pet assign new pet.
Pet.
Assign new pet.
Yeah. Okay. Yeah. That's what I did just a minute ago. Okay. Pet.
I was about to ask about it. Will line 5 execute since there is no breed inside?
No.
It will not execute.
No, sure. I mean, no. We said that already. I mean, we said that if this is pet, it doesn't matter if it is dog or pet, okay? If this is p pet, this line will not execute, will not compile.
Okay, so the question that follows it, okay, let's say this line isn't there. Now we cast pipet to pdog. Will there be a space?
You mean assign?
Assign, yes.
You can, yeah, like this one, you mean?
Yes.
Yeah,
This
okay.
line is there, the line above it is
Yeah.
we cancelled that.
You mean
Will there be
here
space?
we have a pet,
Yes,
we have a pet and we did this, we didn't do this and we did this.
yes.
It is exactly the same case that I discussed, yeah, okay.
Will there be a place for breed at all? Or
No, of course there will not be, there will not be a legal place for breed, okay? But when you try to access the breed using this dog pointer, it will try to write somewhere here.
yes.
On a memory location that doesn't belong to us. Maybe it belongs to us, but we are using it for something else. Okay? So that's a bad thing. That's like dangling pointer thing, right? So that's what I was saying exactly. Okay? So again, what we are doing is something simple. It might confuse you a little bit. But write this code, exact same code. There are only 4 or 5 combinations of using this, making these assignments, etc. Try to get the compiler errors and try to understand why you are getting the compiler error, and try to work around that compiler error to create bad situations like this. Okay, bad situations like this, and try to see what's going on in the memory by using the debugger. See, the debugger can show you what's going on in the memory, right? Don't use strings, instead use characters and that kind of simple stuff, so that your object is very, very small and you don't run into these string problems, because seeing the strings are kind of difficult. So you will understand what is going on. Actually, once you understand the slicing, you will understand polymorphism better. Why? Because I am getting the same question. Why are we doing this? Didn't we have the same thing? Why are we doing? Why did we didn't need this? Why late binding is so important? Why is it required? I don't need that kind of stuff. And you will understand after you understand the slicing and this kind of pointer stuff. You'll understand the whole thing much better. Okay. Any questions? So tomorrow I will continue from this point on, and I guess you have an exam today, big exam, right? Okay, that's why you are kind of uninterested. Okay, so tomorrow I am expecting you more alert. See you next day.